In your group, see if you can figure this one out. It says the combustion of octane. Write the balanced equation for when carbon dioxide is a reactant and when carbon monoxide is a reactant. Okay, so I want you to write actually two balanced equations. Okay, two. One of them when carbon dioxide is a reactant, and one of them when carbon monoxide is a reactant. Okay, so just given those words, you ought to be able at this point in time be able to write that down. Okay, so why don't you see about that. Okay, all right. So octane, you've memorized your alkanes. And so octane, the oct for 8, so remember octopus has 8 legs, right? Octane has 8 carbons. So the formula for octane is C8H18, okay? And we're going to write down two different equations. One, when you have, when carbon dioxide is a reactant, okay? And since it's combustion in both cases, we have the same reactants, we're just going to end up with different products. And in this case, we're in a situation where we have a limited supply of oxygen. Someone would have to tell you that, okay, for you to know that carbon monoxide is going to be a product. All right, so in this case, I know my product is going to be carbon dioxide and water. And in this case, it's going to be carbon monoxide and water. And so what you need to do there is balance those equations, okay? When you get to the situation where you have larger molecules, bigger numbers, sometimes it gets a little bit tricky, especially if you have an odd number, as you do in this case. You have 3 oxygens on this side and 2 on that side, and you've got 8 carbon and 18 hydrogen and all this craziness. The thing to do for these types of combustion reactions is always balance the carbon first, okay? Balance the oxygen last. And normally, if you follow that pattern, you're just fine. Carbon first, then hydrogen, then oxygen. So carbon here, we need 8. Hydrogen, we need 9. Okay, and then when we do that, we end up with 7. Let me see. 8 times 2 is 16 plus 9, 25 oxygen on this side, and we have 2 oxygen on that side. So that's a tricky mess because this is a small odd number, and this is a big, small even number, and this is a big odd number. There's a little trick you can use to balancing in this way, and that is it's kind of like solving linear equations. You can multiply this oxygen O2 by a fraction 25 halves, and 25 halves, my plus is in the way here, but if it weren't, I'd put a 25 halves right in front of that oxygen. And when we're looking at molecules, we don't think that we can, have a half of a molecule in an equation because molecules come as whole units. But as we'll see, when we move on to the next couple chapters down the road, we can interpret these coefficients as individual molecules, 25 halves molecules, or in terms of units. And the unit that's normally used in chemistry is the mole. All right, don't worry about that right now, but some of you may have that prior knowledge. We'll talk about the mole later on. Right now, we're just thinking of this as in terms of units, individuals. 1 octane molecule, 25 halves molecules of oxygen. You just can't leave that fraction in there. It doesn't make any sense in that way because you can't have a half of a molecule. So what you can do, though, is you just use it as a problem-solving tool to get things balanced. Now you have 25 halves times 2 is 25. It's balanced. Then you just clear the fraction. Just like any kind of algebraic work. Multiply 2 times both sides of the equation, and then it'll come balanced. The fraction clears. And there you go. It's balanced. Okay? You can do the same thing for this particular equation. Take time out right now to figure it out yourself. I'm not going to go through the details of it. I'm just going to give you the answer. In this case, if we have let me see. Whoops. How did I mess that up? I have made some sort of a strange mistake here. Oh, no, I did it right. That's right. Okay, that's right. Very good. Okay, the answer for this one, where carbon monoxide is the product, you can work it out yourself. Stop the tape. Don't look at my answer until you've had a chance to work it out yourself because I don't want to spoil it for you. Okay. All right, so once you work it out, this is what you should get for your, yeah, for your answer. That's right. And so in this case, we have 17 oxygen, in this case 25, and that's the difference.